It is sometimes said that steel is heavier than wood. Now, that statement cannot actually be true, because if we take a very small piece of steel and a very large piece of wood, well, the wood will have a larger mass and therefore will have a higher weight. So what exactly do people say when they mean a certain object is heavier than another object? What they actually mean by that statement is that object is more dense than the second object. So heaviness simply refers to the object's density. Now, density is an intensive property that's given by the Greek letter rho. So the formula for density is mass of that object given in kilograms divided by the volume of the object that we're considering given in meters cubed. So the units of density are kilograms per meter cubed. Now, just earlier we said that density is an intensive property. What that basically means is density does not depend on the quantity of object that we are using. So any particular pure object has an identical density regardless of the shape, size, and mass of our object that we are using. For example, if our pure object is pure gold, if we take a very large gold nugget and a very small gold nugget, well, the two nuggets will have the same exact density, regardless of the quantity of gold that we are considering. So, let's suppose we take a certain pure object and we take a cubic chunk of that object. So that cubic chunk is shown here. So we have the following three-dimensional cubic chunk where our length of the object is L, the height is L, and the width is L. So these blue particles are simply the atoms that compose our substance. And in this case, let's say the number of atoms inside this cubic volume is N. And each one of these atoms has a mass lowercase m. Then using those quantities, we can calculate the density of this object using the following formula. We take the mass of the individual atom and we multiply it by the number of atoms. In this case, we have n atoms, and divide that by the volume. And because we're dealing with a cube, the volume is simply L times L times L, so L cubed. So this is equal to the total mass of our object divided by the volume that we're considering. So whenever we say a certain object is more dense than another object per some given volume, what we're actually saying is there are more atoms found in that object in that given volume. So a certain object is said to be more dense or heavier than another object if that first object has more atoms in that same given volume region. Now, from this equation, we can deduce two important equations. Let's look at part A. So let's suppose we take this equation, we take the volume and bring it to the left side of the equation. And we see that the mass of the object we're considering is equal to the density of that object multiplied by the volume of that object. And this gives us the mass of our object. So this equation is very useful when we're considering fluids. Let's look at part B. Let's suppose we take the mass of the object and multiply it by g. Well, the mass times the gravitational constant g is simply the weight of the object. So if we take the mass and we replace it with this quantity, we see that the weight of the object is equal to the density of the object multiplied by the volume multiplied by the gravitational constant g, and this gives us the weight of the object, and this equation is useful when we're considering fluids. So let's look at the following example. Find the mass of a solid steel wrecking ball with a radius of 20 centimeters and a density of 7.8 times 10 to the 3 kilograms per meter cubed. Now, using the radius of our sphere, we can calculate the volume. And if we take the volume and multiply it by the density of our object, that will give us the mass as per equation A. So the mass of the object is equal to the product of the density and the volume, where the volume of the sphere is simply 4/3 times pi radius cubed, where the radius is simply 20 centimeters. So first we convert 20 centimeters to meters by dividing 20 by 100. We get 0.2 meters. So 0.2 meters cubed multiplied by pi multiplied by 4/3, multiply that by the density, and we get approximately a mass of 261 kilograms. So this is the mass of the steel wrecking ball, and we found the mass by taking the product of the volume of the sphere and the density of steel. Now, another important quantity exists that we should talk about is the specific gravity. The specific gravity of an object is simply the ratio of the density of the substance that we're considering to the density of water at 4 degrees Celsius. Now, you should memorize that at 4 degrees Celsius, the density of water is 1,000 kilograms per meter cubed. And notice that specific gravity, because it's a ratio, we have the same units over the same units, the units cancel, and our quantity of specific gravity becomes unitless. For example, if we examine the specific gravity of mercury, we see that mercury is approximately 13 times more dense than water, because the ratio, this ratio of mercury, the density of mercury to the density of water, is approximately 13.